Let's now look at an example of the present value of perpetuity by working on the one in the packet. Um, and to review, the present value of a perpetuity is just going to be given by the amount of payment divided by the periodic interest rate, and that should allow us to figure out how much money is needed. What's the present value of all of those payments? And now in these sorts of questions in the homework, we could be given any of these parts. We could be given a lump sum payment and asked to find the payment amount. We could be given the payment amount, asked to find the present value, or you could be given the payment amount and the upfront payment and being asked to solve, well, what interest rate would I need to ensure the the perpetuity? Um, so I'll just read the example and then we'll work on solving it. It says, pretend that PLNU is establishing a scholarship worth $20,000 to be awarded to the student who gets the highest grade in Professor Havens' business math class. So imagine that they're going to give out a scholarship each year for the best business math student. Wouldn't that be fun? But it's not going to happen. But they give out scholarships for various accomplishments. So this is hypothetically one they could do. Um, but basically, each year, one student will get this award as a scholarship to help with tuition. And the question is, how much would they need to upfront in order to ensure a scholarship lasts forever? So this is kind of a thing, I don't know, where if a university has a particular series of investments where they could take money and invest in it, they're going to be generating a lot more money back based on their investments. And we could set up a scholarship fund that will never end, assuming we could have that interest available to us forever. And that's kind of what we're asking to solve here. And also forever, like we could ensure that this scholarship never goes dry, assuming that our interest is accruing. And really, the goal is to have our account generate an interest of $20,000 per year, because that's how much we're going to be paying out in the scholarship. But basically, let's just use the formula and we'll kind of see if this makes sense. So the present value of the perpetuity is equal to the payment amount over the periodic interest rate. And in this case, the $20,000 is going to be our payment amount. It's going to be how much PLNU is paying out each month, or each year in this case, to the student. And we're assuming that they're going to earn 4% yearly on investment, so that will be our periodic interest rate. Again, plugged in as a decimal as always, um, which is yearly. But imagine this was monthly or something. We might want to adjust P to compounding if we had a more complex compounding situation. Like say we were compounding monthly and not just given the APY. Um, you might want to take that into account. But you could also have adjust the amount of payments to monthly as well, to which you would want to be careful that your payment amount matches your interest rate in its time frame. But in this case, let's go ahead and do that math. 20,000 divided by 0.04. And this should give us the upfront cost or the upfront amount needed to ensure that this scholarship never goes dry. So basically, if some wealthy donor were to give $500,000 up front, this scholarship would never end. Because and how I could look at this is, well, if I were to get 4% interest on $500,000, well, notice that the math I just did, I took this amount and divided by 0.04. If I multiply 500,000 by 0.04, that will obviously return me back to 20,000, because that's exactly what happens when I divide by it. It does exactly the opposite. So if I figure out, well, what is 4% of that? That's of course $20,000. That's the calculation I just did. And that's the amount of interest that I'll be gaining from that upfront amount. So after 1 year, this interest payment will go into the perpetuity, but the balance of that scholarship fund will not change. Every year it will grow by 4%, and that interest will be given out in perpetuity. And that's kind of the sense of how you can create something that lasts forever. Now, another thing that, now that we've looked at an example that I wanted to make clear is that you need a lot of money up front compared to the payout to make sure it does not go dry. So if you're, this is why they have the saying, people who are wealthy stay wealthy. obviously because of interest. But you need a it's not going to last forever if you don't have enough money. And another thing we could consider, let's just do an additional example. Let's say we have $10,000 and we want to know how much could I set up a perpetuity for with a net amount of $10,000. Let's just say we're using a 4% interest rate again for random choice, but it's probably not necessarily, depending on my investment, might not be realistic. And our question is, how much money would this perpetuity pay out every month if I invested $10,000 into it? So actually, notice that if I just multiply both sides by 0.04, that would give me exactly what I'm looking to solve, the payment amount. But basically, what that would give me is a $400 perpetuity. Basically, I could get $400 a year from that initial investment. But obviously, another thing is you're not really, it's a one-time payment, which is generating this much interest per year in this case. And if you just only use the interest, the balance will never go down, meaning it's going to last forever. And that's the idea of a perpetuity. Uh, that's going to wrap it up for chapter 5 videos. For the next exam, we're gonna go back to chapter 3 just to wrap up a section that we did not cover because it didn't really make sense at the time. And I will be posting a practice exam soon, and I'll be doing a little bit of an exam review session. So check the announcements in Canvas. But see you all in the next video.